Hi all, it's Mr. Yeager for chemistry. We are looking at, here we go, periodic trends today. Okay, periodic trends. We should have hopefully just finished up with the periodic table and the breakdown of the periodic table, the different groups, counting up valence electrons by column, 1, 2, 3, 4, 5, 6, 7, 8. We went over some of the history of stuff, knowing where metals, nonmetals, and metalloids are. Now we are getting into some general trends that we have on the periodic table. There are 3 that we are most interested in. We've got some good activities afterwards for you to kind of really play around with these. But we are looking at what happens as you go across a period to certain properties and what happens as you go down a column. Again, this presentation, the actual PowerPoint was made by another excellent chemistry teacher. So again, always giving a shout out to those that do that for their own work. I'm not going to try to take anybody else's work. All right. So here we go. I will use other people's work, but I won't take credit for it. All right. So we got atomic radius. All right. So the first property we're interested in is basically atomic size. How big is the atom? Okay. What happens to the atomic size as you go across the period, and what happens to the atomic size as you go down the column, down the group, okay? So the official definition for how we actually, you're like sitting there going, we can't even see atoms, how do we measure the size of them, okay? We actually have been able to figure it out based on the distances of the nuclear charge, okay? And we could kind of, that's what we're doing is, it's half the distance between adjacent nuclei. We can see where we have 2 nuclei close together because we can measure their charges, okay? Their positive charge, and there's generally a space that they have between them, okay? And so if I have 2 of those and I take half the distance, well, guess what? That's the radius of the atom, because an atom is a spherical object, a piece of matter, okay? So we have the atomic, it can't, obviously, yes, it can't be completely measured accurately, but there is an estimated value of it, because again, we're measuring charge, so you don't necessarily, that can spread out a little bit, okay? But for all intents and purposes, it's size, okay? What we'll see as you go from right to left, so I know that's kind of weird, so I'm usually used to saying left to right, but if we start on this presentation is trying to show how it increases, which is fine, we're sticking with the idea of increasing. If you go from the right side of the periodic table to the left side, the atomic radius will increase. Okay, so as you start from the right side where the noble gases are, they're going to be your smallest elements, and as you go left back toward the alkali metals, the atom will get, the atomic size of those elements will get larger and larger and larger. Now, maybe a little bit easier to kind of see, as you go from top to bottom, the atom will increase as well. Okay, so you got a little picture there, all right? So this probably helps out a little bit more. The top to bottom is pretty clear. You can see that atom keep on getting larger and larger and larger down the groups. Okay, that's what we're looking at. Very, very good. Okay, as we go from, I'm going to go and say it, left to right, we actually will decrease the atomic radius, as you see. We will decrease. Now, there is a little weird thing going on with the noble gases at the end. I don't want you to worry about that, okay? Again, we're looking at trends. So in general, what is happening to the atomic size as we go across? It is decreasing. There are exceptions, as always, with this stuff, but that's why we're calling it trends, okay? If you look at this from a graphic standpoint, okay, if we look at this graphically, what we're seeing is, sorry, let me kind of show this to you. Basically what we see happening is, as we're going across, this is you going across the periodic table from atomic number 1 to atomic number 2, we decrease, and then we increase again. So this is going this way, we're going down the column. I know it's kind of funky, and we got a good activity for you to be able to see that better. But this would be that you're going down the same group, all the elements at the top, and you can see that they're getting larger. If I focus just on one section, one diagonal, that's you going across a period. So as you go across the period, the atomic radius is decreasing, And then when we start over, we have to start higher again and then go across and decrease and keep kind of following that trend that you see there. So that's what we would use. Graphically, it shows it as well. Ionization energy. Ionization energy is our second property or trend. It's the energy needed to remove an electron from the valence energy level, okay? The energy needed to remove one electron, okay, from that atom. It's going to be one of their outermost electrons, all right? This basically tells you how strong is the nucleus. How strong is the nucleus? If there's a high ionization energy, that nucleus holds those electrons really, really well. If there's a low ionization energy, it cannot hold them very well, all right? So what we see is this increases as you go from left to right, all right? And it will increase as you go from bottom to top, okay? So again, I like to look at it from the side, from top to bottom. I'm going to draw like a very simple periodic table. It's not perfect. As you go down, this will actually decrease. The ionization decreases. As you go across, it increases. Okay? And the way to think about that is the electrons are being held by the protons. If the nucleus is closer to those electrons, it's going to have a greater grip on them. Okay? I always use the example in my classroom of, if everybody tried to scramble out of my room and I was like, hey, you can't, where are you guys going? I might only be able to grab, one of the students that's close to me, but the ones that are in the back of the room, they're going to run away really easily. Okay? So if the electrons are closer to the nucleus, so if you have a smaller atom, it's going to be more difficult to pull those electrons off of it. So once again, we can kind of see this trend here. And I like this one where you actually get to see the names. So as you go down the group, you can see here, helium, neon, argon, that's the noble gases, the ionization energy is decreasing. But if you go across a period, it's increasing. All right? I know you're probably sitting there going, what the heck does this look like? You got to just take your time and go, especially this one showing you the elements, you can sit there and go across the period and go, hey, it's going up. The ionization energy is increasing. All right, last property. Again, only 3 properties we've got to remember. There's one called electronegativity. And this is the ability for an atom to grab an electron from another atom. Okay? Usually in a chemical bond. So 2 atoms are already bonded. They want to be together. But one atom might want to grab those electrons a little bit more than the other ones. Okay? And so we call that electronegativity. All right? This does not include the noble gases because they don't form compounds. So this is only going to go from group 1 through 17, and then we don't include it. Okay? So the atom with the greater electronegativity, they'll have a greater pool of those electrons toward itself versus the other atom it formed a bond with. This matches ionization energy. So electronegativity and ionization energy follow the same trend, and atomic radius is what's opposite. So it increases from left to right, and then it increases from bottom to top, or it decreases from top to bottom. All right? So once again, you can see this with the graphs. This is going down a group. As you go down a group, it decreases. As you go across a period, it increases. All right? So, this is just showing all the different electronegativities. You can look at the numbers there. You can pause it for a minute if you want to take a look. You can see that one of the things, I guess I do like this page. One of the things that I try to point out to people is I like to tell everybody fluorine is the smallest atom and therefore has the highest ionization energy and the highest electronegativity. So one way to remember these trends is if you just remember fluorine, these 3 things about fluorine, if you approach fluorine, the ionization energy and electronegativity are increasing, but the radius is decreasing. You're getting to the smallest atom there. If you move away from fluorine, you do the opposite with those trends. So that does help people. Okay? And then you got this page if you want to, you know, I mean, you can't write it, we're asking you not to write it out on your periodic table this time. I guess you could, because that could be your study guide if you want to fit that on there. But this has all of the different trends. Again, you can see electronegativity and ionization energy go together. This is set up to show where it's always increasing, and that's that. All right, thank you.